Good afternoon. Hello, everybody. Let's just start with this information session about the MIRI Master. I'm Oscar Romero, the Vice Dean of Postgraduate Studies, and the objective today is just to cover the questions you may have about this master and also whatever other question you may have aside. So there are two parts in this presentation. Basically, the first one, a presentation I will do myself, and then the second one is about answering your questions. So first thing first, let's be sure that people at home are following us. Can you please react if you can hear me well? Just writing in the chat, or can you hear me well? Okay, perfect. Thank you. So let's start. So also, before I forget, this session is going to be recorded because afterwards we will make it available in our website. So just in case you want to later double check whatever was said during this session, okay? Okay, so let's start with the master MIRI, which is the master we are going to discuss today. This is the list of contents we are going to follow. First, a brief introduction for those of you that do not know the faculty, then the master itself, and a couple of additional questions that typically we receive, like the enrollment procedure and grants and aids. About the faculty. So the Faculty of Informatics of Barcelona belongs to UPC, which stands for Universitat Politècnica Catalunya, which is a public higher education and research institution. This is one of the biggest universities in south of Europe, with more than 6,000 bachelor and master students. And as a public institution, it has well-rooted values in social responsibility, sustainability, equal opportunities, cooperation, and solidarity. Some indicators about UPC, and I will focus on those that are more interesting for you as master students. First of all, if you realize UPC is a university with quite a big chunk of master and PhD students. So we have almost 24,000 bachelor students, but if you see between master and doctorate, we reach almost 8,000, no? So which is a big proportion, not usual in universities. This can give you already a hint that this university is quite devoted to innovation research, and a master's is a usual way to transmit this knowledge. This can also be seen in another indicator, which is the turnover for research and development projects. In 2021, as you can see, the university raised 72 million euro in funds from research and development projects. So it means that most of the lecturers, and in the case of MIRI, all the lecturers that participate in the master are researchers that are participating in real projects and providing added value from this point of view. And the final one that I would like to highlight is that look at the third column. Basically, this is indicators of our internationalization. UPC and specifically FIB is very strong in this aspect. And one of the things that this can impact on you as a student of the faculty is that there will be a chance to do mobility and study abroad for 1 or 2 semesters during your master. So the faculty is the one taking care of studies in the field of computer science. It's a relatively new faculty. It was born in '76, and the first time they started lecturing was '77, '78. So roughly speaking, 40 years, right? So this is in a university of faculties, not that much of time. But the good thing about FIB is in this period, it's already become one of the reference faculties of computer science in Europe, and especially it's the leading one in Spain. Our mission, obviously, provide education in informatics engineering. We are a computer science faculty. So this is achieved by 2 means. The first one, to promoting the dissemination of information technologies as a basic tool to affect any other field. So basically, computer science and informatics nowadays is an instrumental science that affects any other. And the second one is providing a strong background to our students. So one of the things that is a reality in computer science is this long life learning thing that we need to go through, anybody who is in this field. So it means that one of the main aspects that we can transmit to our students is very strong foundations, so that from there on they can build on their own, right? So we prioritize lasting concepts, and also we promote what it's called traversal skills, like effective working habits and team working, or the ability of self-sufficiency, just to promote this ability to grow on their own based on strong foundations. Additionally, an additional aspect that I also like to highlight is that all our masters are externally evaluated and certified. So this means that, okay, I can come here and just say we are very nice and very good, right? But it's better someone else tells you so. So this is the role of these external agencies. Basically, there are two agencies, one national, one European, that come to UPC, come to faculty. They evaluate our studies and they give a label of quality. In both cases, we have the maximum quality label by both agencies, which is the excellence label of our studies. This is the case for MIRI. And if we check at the reports that this agency is created, by default, if you want to know more, if you go to the faculty page, FIB-UPC.edu, and you go to the quality assessment, the reports created for MIRI by these two agencies are available. You can read them, okay? So a kind or quick summary of what they highlight, basically three things. The agencies highlight that our master, and specifically MIRI, has very high and excellent learning outcomes that our students are very satisfied with. The quality of the teaching staff, this is related with what I said before. All our lecturers are researchers, so what they are teaching in their courses is research and innovation that they are putting in practice in their research projects and projects with companies. And finally, the services and resources that the faculty puts at the service of the students, right? In case you are not aware where the faculty sits, it's in one of the ends of Barcelona. The good thing about Barcelona is that it's not as big as London or Paris, right? So going from this blue marker here to the city center, it takes about 30 minutes by metro. So it's very well connected with the city. And here you have the specific address where we sit, the contact, an email and web, and also the social networks in case you want to follow us to know more about the faculty. Okay, so once said all this, let's go for the discussion about the MIRI Master and what is providing. This master stands for Innovation and Research in Informatics. So this rings a bell why, when I was discussing the key indicators from UPC, I was focusing more on research aspects. It's because this master is very much focused on this, in these two aspects. It has 4 fields of expertise, so it means that you can go in depth in one of these 4 aspects covered in the master: advanced computing, computer graphics and virtual reality, computer networks and distributed systems, and finally high-performance computing. When you start the master, you need to choose, okay? The master is 2 years, and it's taught in English. Then when you start these 2 years, there are 30 ECTS, most of them in the first semester, but at least one course is in the second semester, are common independent of the specialization you take. So basically, these are courses that are meant to give you strong foundations in mathematics for research. So you learn how to conduct experiments, which is a basic thing in research and innovation, how to develop research and innovation in your future career, seminars, and a final course on distributed systems, okay? These are common regardless of the specialization you take. And these are the foundations that all of you, regardless of the specialization you take, you need for doing research and innovation. Then, besides these 30, you have 48 that are specific of the specialization you take. For example, if I take advanced computing, I will be taking 48 credits focused on this topic, okay? Then there are 12 elective, which mean basically that they should be in the focus of computer science, but you decide on what you want to do it, and then 30 in the master thesis. The master thesis of this master must be also in the research aspect, so it's a demanding thesis, okay, of about 900 hours, so it requires quite a lot of work here, and I will go more into detail later. So if we want to know more about the master, there are these links here. Just let me open one of them to show you how the curriculum of this master looks like. This takes you to the masters.fib.upc.edu website, where all the information about our masters is. Now here I'm specifically in the advanced computing specialization of MIRI. So here you can check the curriculum, and you will see the courses that are mandatory in the first semester. This course is about algorithmic methods for mathematical models. The second one is concurrence, parallelism, and distributed systems. The statistical model and design of experiments, and finally, techniques and methodology of innovation, research, and informatics. These are the 4 courses that are common for all the specializations and focused on give you a strong background to do innovation and research, okay? So mathematical background, experimentation, how to do experiments, knowledge in distributed systems, which is key nowadays, and techniques about how to read papers, how to write papers, how to do a search on a topic that you don't master, and just learn what the current state of the art is, which is the MIRI, right? The one that is missing here, the other, because there are 30 ECTS, right, that is mandatory, is the seminar activities. But the seminar activities is a kind of non-traditional course. This is a research and innovation master. So it's impossible that we can cope with all the innovations that appear just with courses. So we have one course here, which is only specific devoted for seminars that are typically covered with trending things that are happening that you should decide what to take, okay? It's up to you. There is a website where the seminars appear. You go there and just enroll them. You can enroll to this seminar during the whole master. So it's not that you take this course in one semester. You just take the activities during the master. When you have them all, up to 30 CTS, you recognize it, okay? So that's why there are 4 in the first semester. The 5th that you see, for example, in this example, this is a specific of this specialization, which is advanced computing, okay? If you check the other specializations here, you will find one course which is a specific of the others. Okay? So basically the structure is very similar. This orangish color, it means that these are mandatory courses. The blue ones are the elective courses, okay? So there are the 5 courses common for all the specializations. You have then 4 additional courses for each specialization, right? And then the elective ones of the specialization. Finally, you have general elective courses, where you can take other courses from other specializations, from other masters from the faculty, or even from the UPC, right? As I will explain later as well, these 12 course ECTS here, the 2 elective courses, can also be covered with internships or working during that period. This is another way to cover them, okay? And finally, the master thesis. So as you see, this is a master thought to be covered in 4 semesters, 2 years, okay? So it's a 120 ECTS master. As I said, during your studies, you can take curricular internships, so it means to claim later up to 12 ECTS out of it. Also, if you have a regular job and you are not doing an internship, also from this job you can also claim ECTS. And finally, the last important thing, basic for this master, is that if you apply to a specialization and you have some gap in your CV, the commission that will evaluate your CV might ask you to do some complementary course before starting the master, okay? So what may happen is that you need to conduct 1, 2 courses at the beginning of the master. If it's only 1 or 2, we allow you to take these courses in parallel with others from the master, okay? It's not that you need to spend a semester with only the complementary courses, but you need to take them. So this master has a very strong research and innovation orientation, right? So, and this is where we excel, and this is something that I would like to discuss with you here, is that UPC nowadays is a leading research institution in research. So just to show you some metrics that back up what I'm saying now here. So recently there was some news that UPC was the top university raising funds from the H2020 projects from Spain, okay? H2020 projects are these high-level, cutting-edge projects in research funded by the European Union, where universities need to work with companies to just bring innovation to companies, right? So UPC was the top university in Spain, one of the top in Europe, rising H2020 funding. The second one, we are leading in Spain, the university creating more startups, spin-offs, and doing technology transfer. And also that you may have not heard of it, but also UPC is one of the first universities that had a Center for Development Cooperation. So it means that you can participate in projects to help or to develop projects in third world countries or undeveloped countries. Okay. The other interesting thing is that during your master, you can participate doing research in some research groups. Okay, and in this master is very natural. It's something that you should be keen on doing, because as I will explain in a while, the orientation of this master is in this direction. All the lecturers that you will have in the master are researchers. It means that they participate in real projects. This is key, because then in the lectures that you will find, they are bringing all this knowledge to the lectures. And finally, typically the way to formalize, so how do you do research, right, when you are a student? Typically formalizing this with either an internship or something we call a research grant, okay? Typically this is done with a research group or a research institution, like for example, the Barcelona Supercomputing Center, okay? Let's go for one by one for the specializations. I will start with advanced computing, okay? So this specialization has as an objective what you can read here. There are some very complex, from a computational point of view, problems, right? So that they cannot be solved in a naive way, with naive programming skills. So in this specialization, you go deeper in understanding the limits of computation. So what are the difficulties and the complexity that you may find? I'm pretty sure that you may have already be aware of the P and NP problems, right? So when you are in a kind of an NP problem, very complex, how do you tackle it from a programming perspective, okay? So here, what you learn is methods, techniques to develop novel and efficient algorithmic solutions when by brute force, the solution might not be feasible, okay? So what are the strategies out there? So basically you have analytic tools or skills, whatever, just to understand the fundamental principles of computing and build on top of that. Where do you apply this? Nowadays, in many aspects of the day-by-day life. So one of the most interesting ones, for example, you may have heard of the last mile delivery now that it's very trendy after the pandemic. This is the real problem in logistics for Amazon, for example, right? So how to efficiently deliver the last mile of a product. So in which order do you deliver the parcels and following which route, so that it's optimal and you minimize the time, okay? I'm pretty sure that you are quite annoyed when you are told that the parcel is going to arrive from 3 to 4 and then it arrives at 9 p.m., right? So how to solve this problem? How can you really be very efficient predicting at what time you can deliver a parcel? So to do this, you can use techniques based on graphs, okay? And this is one of the techniques that is used in this specialization just to identify manners of doing this, finding solutions that are realistic and provide value, okay? Another one would be combinatorial problems that appear pretty easily, like when you need to create the fixtures of a league, a football or basketball league, right? You have a lot of combinations, but you have some constraints. Every team needs to play the other team twice and in a certain order, right? So how to just create the fixtures in an automatic way? This is another way that by brute force, the number of combinations is too high. So you need to find a smart way to come up with a solution. So this is what is called the intelligent systems, but this is applied in many other aspects. Social networks. Social networks are typically nowadays described as graphs. You may know that the graph algorithms are very expensive from a computational point of view. So when a graph is very, very large, computing something like, I don't know, the shortest path between 2 points can be very expensive, right? So how to do it in a smart way? To automate and speed up mathematical algorithms that are key or basic in machine learning and data mining that do not scale up well, and they are very costly because they are iterative. How to find solutions for this, for human language processing, etc., etc. If you are interested in this specialization, one of the usual ways to do this specialization is to participate in research groups that are focused on these algorithmic aspects, okay? I listed here the 4 groups that are typically tightly related to this specialization. As you can see from the titles, they are based in algorithms. The first one, computational biology, complexity, formal methods, relational algorithms. You can see that it's all in the direction I was mentioning. And then the job opportunities, this is based on our alumni. So some of them are in the academy nowadays, in local or international universities, and big tech companies like Google or Amazon that they have problems that are, from a computational point of view, non-traditional. Assisted design of computer assisted design, which would be the third option, and obviously the field of data science nowadays. These are two exemplary master theses of students that after doing this specialization conducted at the end. So the first one by Josep Sanchez is basically a solution that when you need to model the processes in a company, inside a company, typically this is done with a notation called BPM that can be very difficult to describe. So what he did in his thesis is just to facilitate doing so. And how did he do it? Basically, you can do with human natural language annotations, express what you want, and then try to generate automatically the process description, which would not be that different today with the so popular ChatGPT and the prompt engineering, no? That you write a prompt and somehow this is translated in a solution. This would be the same idea, no? You have a text, kind of a prompt, and from this prompt you derive the design of this process automatically. This was an outstanding thesis, and from here there was a spin-off creation, a patent, and also he conducted a PhD afterwards in this topic, and continuing developing new advances related to this spin-off. The second one by Juan Pablo Royo is basically a problem to provide an algorithmic solution for enumerating B-triangles in large bipartite networks. So why this can be interesting? Basically, bipartite networks are interesting nowadays. For example, when you have two big classes that they relate to each other. For example, think of e-commerce. You have customers and you have items, right? So when you need to relate these two elements, these two sets, basically one way to identify interesting trends is just finding triangles between these two sets, right? For example, if there are two customers that relate to the same object or item that they bought, this could be a recommendation for you, no? Because maybe this is something interesting for the other person, right? So this is kind of techniques that nowadays are hot topic in order to later do recommendations or to understand your customers. Juan Pablo, for example, created a software that is open source and created a publication out of it. Okay. The second specialization is computer graphics and virtual reality. This is basically the state of the art on computer graphics. So typically when I talk about computer graphics, people tell me this is only video games, and it's not, okay? Video games is one part of it, but I just added other examples here of what people, after doing this specialization, typically work. There is a lot of work here in the sense of medicine and architecture, all these digital twins that are so popular nowadays. Cultural heritage, specifically after the pandemic, when a lot of museums had to close their doors, and they created simulations that you could visit the museum, no, from your computer. And this is typically also related with the second point here, which is virtual reality. So what are the opportunities here? So basically, there is a big group of virtual reality and graphics, which is called VIRVIC. So most of the students that participate in this specialization participate in this research group as well. So this is very much participating in their projects. You have some examples here of projects. This is a digital twin, right, where you are representing a person with a digital twin. Then something happens to the digital twin, and you simulate whatever is going on. Biology and medicine, the examples below. Cultural heritage, simulation of how people might move in a big place with a lot of people going around, etc., etc. Besides the research aspects, the alumni of this specialization typically go to companies in the sector of engineering, medical imaging, video games, of course, and so on and so forth. So you have some of the centers of where some of our alumni from this specialization are working nowadays. Two theses that would be exemplary for this one. The first one is, as we said, for cultural heritage. So if you want to use virtual reality for people be able to explore the museum from the distance, no, from their home or whatever, this, as I said, was pretty trendy with the pandemic, this was pretty speed up at that moment. And now, if you check, many museums out there, they have already these kind of experiences. So this was one master thesis from Arnau Farras. And the second one, which is another typical usage of computer graphics, is for simulations in health. Okay, in this case, it was just molecular simulation trajectories and how to do the simulation from a graphical perspective. This is a master thesis from David Duran. The third specialization is computer networks and distributed systems. So basically, this specialization focuses on distributing systems, right? So nowadays, distributed systems are everywhere, even if we are not aware of them. So anything related with cloud computing, IoT systems, big data, P2P networks, all these, what they have behind is a distributed system. So a distributed system relies on a computer network, right? So the computer network is the more hardware-based specific infrastructure, and the distributed system is a software system that builds on top of these networks to create the system that does something, no? A cloud computing or whatever. Here you have the topics covered. So basically, it's cloud computing fundamentals and also services provided by the cloud, like the ones that you may hear, no? Like Google, AWS, Azure from Microsoft, etc. IoT systems, these are distributed network systems, like the big data analytics in the cloud, it's also a distributed one. Another topic that is pretty trending in this field, and two of the courses of this specialization are devoted, is how to use machine learning and deep learning techniques to improve the quality of the data you gather from sensors or distributed systems to do whatever with them, right? And the traditional aspects of the distributed system, which would be the three last ones, P2P, subscriptions, group communication, and content and media distribution, right? What are the opportunities here? And these are the research groups related in our faculty related to distributed systems and computer networks. No? The first one is more from a statistical point of view. So basically, this is the group that basically is doing machine learning and deep learning for data quality or analysis of the networks or the systems. Then you have the typical group on creating these distributed systems like cloud computing or decentralized systems. Another one more in the side of virtualization, which is kind of key in this kind of systems, broadband communication systems, and of course, high-performance computing, right? Two theses to show what the students that finalize here can do. The first one is by Pau Marcet, and it's called Applying Blockchain to Secure a Distributed Set of Clusters. This master thesis is because when you have a distributed system, basically, it kills security, because security always requires a centralized authority, right? So like the typical certificates that you are aware of. So here what they were exploring was how can we just develop an innovative way to replace traditional centralized certificates in a distributed manner, and they did it with blockchain, okay? The second thesis is by Pau Ferrer, and it's another relevant topic. It's basically, in this case, the calibration of low-cost air pollutant sensors using machine learning techniques. Basically, if you have a lot of sensors that are taking measures, how can I create a distributed system that is able to do the analysis of these individual points and combine it to make a final overall conclusion? This is what is called nowadays like federated learning. Okay, federated learning basically is you learn independently and then you combine your knowledge to create an overall knowledge. And the last one is high performance computing. So sometimes the problem is so high or so big that you cannot solve it with a distributed system. You need something bigger, right? And the solution for this is a supercomputer. So you know that we have a supercomputer just in the campus, which is the Barcelona Supercomputing Center. This would be the specialization that naturally relates to high-performance computing, which is basically how to use a supercomputer. A supercomputer has different ways of working. It's different to a distributed system. It's not just simply a network with different machines participating. A supercomputer has a different architecture, has a different way to develop the code. Coding in a supercomputer is also different. And also the kind of things that you may want to do there need to be prepared to run in distributed environments run by a supercomputer. So nowadays, supercomputers can be used for anything, for very big problems, like, I don't know, analyzing all the data from the space that all these devices we have exploring the space are capturing, or to make predictions about oil and gas, right? Or to automate or speed up what is quite trendy nowadays, these artificial intelligence methods that are based in deep learning and require a crazy amount of resources to train the models, even during months, etc., right? So it is more focused for this kind of another level, not something that every company may have, because supercomputers that are very few and spread all over Europe, no? And this is the companies hire the services of these supercomputers when they need something out of the usual computational requirements. We have several groups participating here in this specialization, but basically, as you may know, UPC participates in the Barcelona Supercomputing Center, so it means that these research groups have one foot at UPC in the faculty and one foot in the Barcelona Supercomputing Center. So the usual path that all the students follow in this specialization is doing the research experience at BSc. So what is the kind of professional opportunities participate in the design of future processors? You may know now that BSc is the leading institution developing the new generation of European processors called RISC-V. Okay, develop supercomputer applications, so coding on a supercomputer, improving performance, and obviously all this training of AI, data science that is pretty trending nowadays. If you are interested in this specialization, here important for you. This specialization participates in a bigger initiative, which is the European for High Performance Computing, which is an international European master. This is the link here. Okay, this master is just an effort from Europe trying to develop a strong European supercomputing network, because as you know, it's essential, it's strategic for Europe that we have strong computational capacities just to compete with other actors in the worldwide, like China or the States, where they have a lot of trained people in this aspect. So this was one of the pillars that the European Union said that we should focus efforts. So strategically, they created a new project that will become a new supercomputer, European supercomputer that will be hosted here in Barcelona. And this master, the EU for HPC, is the international European effort to train people in HPC, no? Because if you are developing a new strategy, you need people also to develop it, no? So if you are interested in this master in MIRI and this specialization, please check it, because we participate in this initiative with this specialization. So people who go to the EU for HPC from staying at UPC do exactly the same courses as MIRI HPC. Okay, what is the difference? If you go to the EU for HPC, you do 1 year in Barcelona, then you must move to another university of the consortium in the second year. So it's a double degree. Okay, you need to move somewhere else and study abroad in the second year. If you do it purely MIRI HPC, you can do the 2 years in Barcelona. Okay, that's the only difference. So please, if you would be keen on doing mobility, then it's better to apply directly to EU for HPC, because among other things, you can get a grant and you can get your tuition fees covered as well. So you can get money out of it, okay? Just consider it in case you like it. Thesis related to this specialization. The first one by Joel Sanchez is analysis and optimization of a debug post-silicon hardware architecture. Basically here what they are doing is developing the next generation architecture of European processors, okay, the RISC-V initiative. So a lot of our master thesis in this specialization are there, improving aspects of this new generation of processors. And the second one is another traditional aspect by Marc Solé, basically how to use HPC to train faster very large AI models or data science models. Okay, So these are the specialization itself. As you saw during the specialization, one of the things that I was highlighting is that if you want to take the most out of it, one of them in regular ways is to go to one of the research groups, okay? So how to formalize the collaboration with a research group? Typically with an internship. So internships in our own jargon, this is called Convenis de Colaboració Universitat Empresa, CCE, okay? And basically this is the regulations you must follow in order to do an internship while doing your master thesis. Your master, sorry. It can be the master thesis or can be just a regular internship during the master. So this is what we call industrial practices. If you go to this link, you have all the detail here, information for companies, information for students, and the regulations. Basically, the regulations are, as a master student, you need to be paid a minimum amount of money, okay, so per hour. And also, when you sign an internship with a company, the company, you and the faculty sign an agreement of what you are going to do there. This is just to protect that what you are going to do at the company is related to the studies, okay? So then the companies need to honor whatever they signed and cover these specific topics. This is working very well. Most of our students sign internships. We don't have problems. Companies really like the profiles that we generate in this master, and typically they are in research centers, in companies, research groups, in conducting their internships. So if you are interested, please go to this website. You may know the details how these internships works. From a curricular point of view, if you remember, I told you that there are 12 elective ECTS in this master, so you can cover them doing internships. Okay, so you can cover the elective ECTS, minimum 6 and maximum 12, plus the master thesis. The master thesis goes aside. You can do 12 ECTS curricular, plus the master thesis in a company or a research center. This is fine, okay? If you do so, this is what we call the master thesis modality B at a company, or D at a foreign company, or a foreign institution. And the rule of thumb that you need to follow is that to claim 6 ECTS, you need to know that you need to do 36 times, no? Because 30 hours is considered 1 ECTS. So the minimum would be 6 times 30 hours and the maximum 12 hours, 30 hours. There is a maximum of hours that you can do per year as a student in internships, just to be sure that you are also studying, no? So just don't get crazy doing a crazy large amount of hours doing internships. The maximum is 900 hours, which is quite large. You are entitled to do quite a lot of things there. And additional, you may account for 450 additional ones for a total of 1,300 something if you also consider the master thesis. If you don't do an internship, but still you are with a job contract somewhere, you can claim also the 12 ECTS, the elective ECTS, just recognizing your professional experience. So if you have a job contract previous or during the master related to the content of the master, okay, then for every 1,600 hours, you can get recognized 6 credits, elective credits again, and then proportional from here on. Okay. Another interesting aspect, you can do all this research innovation with companies, research group here. Another way is to go somewhere else, at an abroad university or an abroad company. And this is one of the biggest strengths of our university and our faculty. FIB right now has agreements with 202 universities in 42 different countries. And we have a lot of different frameworks where we participate to enable mobility programs. I'm a big fan of mobility. As a vice dean of the faculty, I always encourage the students to do mobility. It's true that mobility is not cheap, because you need to many times live somewhere else, and sometimes Northern Europe might not be cheap, right? But the good news, to some extent, is that these mobility programs typically go with a grant. This grant is not that much, so it's not that you are becoming rich with these grants. They barely cover the expenses to just go there and get a flat, right? But it's a help, okay, better than nothing. What are these mobility programs? We have mobility program with CERN in Switzerland, the famous Erasmus Plus that you may know, but we have plenty of others with Japan, Latin America, the USA, Canada, China, etc. Okay. We also have the options to go for a double degree. The difference between mobility and double degree is that when you go for a mobility semester abroad, you just do the study there, you come back, and then the credits you did abroad, and they are recognized at FIB, right? If you do a double degree, besides doing this, you are earning the degree from FIB and also the degree from the hosting institution, okay? So you get two. And also you can do internships. So you can do an internship in a research center in a company. So you don't really need just to go abroad to do a semester in another university. Yeah? So these are also, again, different frameworks, Erasmus+, IAESTE, so on and so forth. These internships can be done in research groups in academy or in industry. Okay, this is fine. Or even other activities like summer schools, stay in CERN, so on. If you are interested, we have a website fully devoted to this. If you go to this link, please go to the outgoing. These are the options that you, as a student, once you enroll in a master, you get to move abroad. Okay, and here you have all the details and so on. And finally, if you are interested in MIRI, how to do the enrollment. Okay, so this is a 6 steps procedure. So the first one is to register. I will tell you now where you find the link to register. You need to register by entering all your personal and academic details. Then once you have entered all this information, you need to pay a tax of 30 euro. When this is paid, your application reaches to the selection committee that is going to evaluate your CV. This commission is going to give you an outcome that typically is reject or accept. Okay. If you are accepted, well, first of all, congratulations. And the second thing is that you need to accept the position, right? Some of our masters, they have a high demand. So one of the things that we implemented at the faculty is that after you get the confirmation that you got the position, you have around 1 week to confirm you want to take the master. Okay? If you want to take the master, the way to secure your place next year is paying 300 euros. That this is not a tax. This is money that will be deducted from your first enrollment. Okay, so you are paying in advance, just showing interest in the master. This is just to guarantee that people are not just blocking seats. Okay, and finally, you do the typical enrollment procedure. There is 1 day that you need to do the enrollment. The enrollment is typically the last week of July, and it's online. Okay? So we have 2 enrollment periods. Well, the whole enrollment period goes from the 27th to 26th. Enrollment period, I mean to do the 2 first steps, right? The first one has already passed, but you have the second one that finishes the 26th of May. So if you apply by this date, our intention is to answer by the 2nd of June, and then you will know if you are accepted or not in the master. If there are available seats after this application, we may open a 3rd period. This will depend on how many applications we have in the first 2 periods and if there are available seats or not to be opened. If so, then we open a 3rd period that its tentative deadline would be the end of June and the tentative admission notification by the beginning of July. Okay. For the admission, please go to the website of masters.fib-UPC.edu, check the admission criteria of MIRI, and check what the commissions are going to check. One of the things that you need to write is a motivation letter. So please pay attention to the motivation letter, explain why you want to take the master, what is the added value you think you are going to extract from this experience, why this is your interest, okay? Don't simplify the procedure of being selected in a master by just checking the marks of the bachelor. The marks of the bachelor are always important, of course, but there are many other things that might make you an interesting master student. So just motivate well why you want to do the master and what are your strengths. Okay. So how to do the pre-enrollment? So you need to go to this website, the masters.fib-UPC.edu, then just look for the master you are interested. For example, imagine high performance computing. Then if you scroll down, here you will find this part here where you have a video explaining how to do it, but basically it's clicking this blue button here and following the instructions. You need to register. introduce all your personal and academic information, and then pay the tax. And that's it, okay? A typical question we get is that the blue button doesn't appear, so I cannot continue to pay the tax after introducing my information. If this happens, it's because you forgot to add either some personal information or academic information. You need to introduce all the information required there, okay? Otherwise, the button to pay the tax does not appear. So what are the prices for the master? So it seems that even if the prices for next year are published typically by the local government in July, okay, it looks like that the prices are going to be like this for next year, the ones that you can see in the screen. So for European Union applicants, the price is 27 something ECTS, euro per ECTS. If you are non-European, the price is higher because the price is different if you have been a taxpayer in the country or not, right? So this is subsidized or is not subsidized. That's why you have two different prices for ECTS. More information. If you have information about how to do the registration, you have doubts what kind of paper or what kind of documentation you need to justify your English level, whatever. Our information email is info.masters@fib-upc.edu. But if you have academic questions, like for example, I would like to know if I take this specialization, how likely is that I will be working in this kind of company, or I can do a PhD later easily here at UPC in this topic. Whatever academic aspect you may want to have doubts, please contact the coordinator of the specialization. So you have them here. The first one is advanced computing, graphics, distributed systems, and HPC. Okay, so each of them is coordinated by a different coordinator, and you have the emails here. You have also the links that I included here for the websites in case you want to go specifically to one of them, and also the academic calendars just to have an idea how the semesters are structured at UPC in case you are not familiar how UPC structures the year. And last but not least, is that we have specific grants for our master students. It means that, as I said, our masters are well recognized. They are appreciated by companies and organizations. So many times we have companies or organizations willing to grant our students some bursaries. Okay. You have two kinds of grants here. Grants coming from companies in the IT sector that typically they cover your tuition fees, but then they will be expecting that you do internships with them. Or then non-profit organizations that then they are covering your tuition fees and sometimes not asking for anything in return. But sometimes these organizations, they are promoting like women in IT or computer science or things like that, okay? So this is the link where you can check the grants that will be available. This is too early now to check the grants that we will have this year. Grants are typically published after the acceptance. So typically by July, September is when you apply to the grants, okay? It's for people who have already been accepted in masters. But just to give you a hint what kind of grants you may have, you can go to this link because you will see the ones that were offered last year, okay? So you will see that here is a mix of companies and organizations. And then the typical questions that you may have. Now we will open a turn for questions, but just advancing myself here. A typical question is, what if I'm an undergraduate student that didn't finish yet? Can I apply to a master? And the answer is yes. So then you are conditionally admitted to finish your studies. You need to finish your studies fully before September, or in the worst case, there is the option that if only the bachelor thesis is missing, to finalize it in October. But if this is the case, please contact us at info.masters so we can give you more hints about this way. If you are a UPC student, there is a third option, is what is called starting the master without finishing the bachelor. This is yet another option, different to the one that I'm explaining here. We have a specific talk for this, 3rd of May. It's in the website of FIB and in RACO, in case that you are a FIB student. You can enroll there, and then we will explain the specific details for UPC students to start the master without finishing the bachelor, which is something pretty new that comes from a new regulation that was developed in Spain, okay? The second thing, can I work and study at the same time? And this is a big yes, of course, right? This is something pretty usual. This is why we have the internships that I explained you. We can recognize the time that you are working. If you are with an internship or something like that, please just be aware that then you most probably want to do then the studies, the master, part-time. Okay, this is possible. The first time you enroll in our masters, you are asked if you are going to take the master part-time or full-time. If you take it part-time, you have at most 18 ACTS per semester. So it's half of the workload of the semester, more or less. So then you are supposed to be working the other half, okay? So this is perfectly fine. Then in MIRI, since most of the work is done in research centers like the Barcelona Supercomputing Center or research groups, this is very easy to handle, no? Because the research centers acknowledge very well that you will be studying for a certain number of hours. So you are doing the master and then working with them the rest of the time, because with 18 ECTS, you roughly are taking 3 courses per semester, okay? So we expect to not have problems with COVID-19. This year was fully face-to-face and without problems. We expect the same for the next one. And finally, if you are a new student, especially coming from abroad, and it's a problem to be here the first day of enrollment, that will be at the end of July, once accepted and you have booked your position at the master, just to let you know that registration will be online. So you can just do it. You need a connection to internet just to do the registration at the day and hour that you are assigned for enrollment. Okay, this is an information that is sent to you, and you just need to honor the time and day you were provided. So just be sure to be online at that time, and you will be able to formalize your enrollment. Okay. And with this, as I said, if you have main questions from an administrative point of view, please contact us at info.masters. And now we will start a turn of questions, okay, the second part of the discussion. We have activated the chat for those of you at home. So please, if you have questions, write your question in the chat. I will read the questions in the chat and will provide answers aloud, so everybody, people here and online, can hear the answer. And while you write your questions online, let's just start with the people here face-to-face. If you have questions, please raise your hand, and Montse will just approach the mic to you. Any question? No? Okay. So what about home? Any question? Okay, Jin Choi is asking, hi Oscar, thank you for the presentation. I'm already a professional software engineer, but looking to enhance my expertise. However, I have a bachelor in industrial design. I'm curious if my unconventional background would be accepted as long as my motivation letter is good enough. Also, I achieved my degree in South Korea. Would this be an issue? Not, where you achieve your degree is not an issue as long as the background is enough. I'm afraid that I'm not that familiar with industrial and design, so I might not be able to answer your question straightforwardly. So what I would say is that an easy way is that you apply and you will see from the commission if this is acceptable or not. What I can foresee is that most probably you will need to do some complementary courses. Okay. Another option is that you contact the academic responsible of the specialization that you would like to pursue. Right here you have the 4 of them, so maybe the easiest way is just contact the person responsible for the specialization you like the most and ask them. Most probably as well, I would suggest that you provide also the courses that you took in your bachelor and your experience as a software engineer, so they can assess. Obviously, just be aware that by email it will be a kind of an unofficial quick assessment to give you some hints. It will never be a definitive one, so you really need to apply, and the commission has the last word, but at least they can orient you and give you some hints about your background. Okay. Any other question? You're welcome. Oh yes, we have a question here. One second, that we will bring the mic, otherwise people at home will not hear you.
If you have already graduated, but you still need to legalize your title, but like it takes more time than the admission period, is there an option to just hold that title?
Yes, typically what we do is that for the when you apply, it's not necessary that it's legalized. But then if you are accepted, that's from the faculty, they will contact you, they will give you the timing, how to provide these documents. So if you already are concerned about this, just write to info.masters, explain what is your situation, and they will give you the details. But this is something pretty usual, that sometimes it requires more time to get some papers. Just get in contact with our administration, they will let you know.
Okay, thanks.
But it should not be a problem. Any other question? Because we don't have questions at home. We typically have a lot of questions. So either today I was very informative, or is that fine? No questions at all? You're fine? Okay. So then we are done, right? So thank you all for your interest in our master, and I hope I can see you as students in the next year. So thanks again. Okay, thank you, Arvin. Thanks again, and remember that we will put our our recording online in the master's website. Okay, just give us some days, and then the slides and the recording will appear there, so you can also double check. Okay. Again, thank you for your time.